In this video we're going to start creating this lamp. Let's have a look at the features of this lamp. Well, it's pretty much two main parts. There's a shade and there's a stand, and the stand itself has got a couple of parts to it. There's the length that we can alter of the pole here, and there's also the base at the bottom. We can change the spread and the height of that base. Now the shade itself, we can scale up and down, we can change its radius, and there's also a kind of characteristic here which is called cut, and it just changes the shape of the shade. You can also, of course, fiddle with the colours here and change those to something completely different if we so choose. Okay, so we're going to look at creating this lamp from scratch. Here's the network that defines the stand, and we can see that it's broken into two main parts. There's a molecule for the stand and there's a molecule for the shade. Both of those are fed into a camera, which we'll have a brief look at later in this series, but there will be a separate video on cameras. So first of all, I'm going to create the stand, then I'm going to create the shade. So let's start with the stand. I have a brand new empty spoke here. First thing I'll do is create a new molecule to put the stand in, and I'm going to dive into that molecule, and this is where I'm going to create the stand. The first thing I'm going to do to create the stand is make a profile for the curve which is going to define the base of the stand. So I'm going to switch to a front view axis there, front view ground plane rather, so that when I create a points atom, I can just draw directly on that, and I'm going to draw a profile for a curve and connect those points together with a points to curve. And I want to be able to scale the base. I want to be able to make it taller, and I also want to be able to make it spread across the x-axis too. So I'm going to create a scale node. Both the base height and the spread of the base are two parameters that I want to be able to expose. So I'm going to create sticky parameters for both of those. Create a couple of floats. Call one of them base height. And the other base spread. Set them to be sticky, and I want to connect these up to change the scale of the height and the spread. Scale takes a three-component vector as an input, and these are individual floats, so I'm going to need to create an XYZ to vector atom there that I can hook this up to. So base height affects the y-axis and the spread affects the x-axis. So I'm just going to select scale and connect it to the vector. And when I select scale at the moment, well, I can't see anything, and that's because both the spread and the height were at 0. So let's change them to be something a little bit more sensible. At this stage too, I probably need to think about what are sensible constraints or minimum and maximum values around things like base height and base spread. So it very much depends on what type of units I'm working with, that kind of thing. For the time being, I'm just going to say that my base height can't be any higher than, say, 10 units, and it can't be any smaller than 1 unit. I'll make the default. Let's make the default 5, so halfway between those. The spread, well, let's do something similar with that. Let's make the default 5, the minimum 1, and the maximum 10. So what does that give us? Nothing, because I haven't selected scale there. So it seems like a reasonable set of values that we have in here now. Aside from the base height and spread, I also want to be able to change how far away this curve is from the center line here. So the spread at the moment scales out on the x-axis, but I also want to be able to move the entire curve backwards and forwards too, because that's going to end up defining how thick the pole is there in the middle. So let's just call this, or let's create another sticky float here and call it base adjust. And we need to hook that up to a move node. I suppose I should probably create that first and get the output of the scale and connect that up to move. Now again, move takes a vector as an input, so I'm going to need to create another XYZ to vector, and I'll hook the base adjust up to the x-axis. And now if I change the base adjust, you can see I can move the curve backwards and forwards along the x-axis. It's now time to rotate that curve around the y-axis and wrap a skin around it so we have a solid base. So that's a two-step process. First, create a copy atom and connect the curve up to it. Now I could, depending on how many copies I want to make, I could really choose any number of things here, but I think I'll go for 37 copies, rotating 10 degrees at a time. There we go. Starting to see the base there. Let's skin it. There we have it. Might just change my ground plane back to along the XZ axis there, XZ plane. I want to create the pole part of the stand, which starts at the top of the base and extends upwards by a number of units. Now I'll first start just by creating a sticky parameter for that. Call it pole height. Make it sticky, and might move that down the bottom here. So the thing about the base is that the height is variable, and I need to start the pole from wherever that top of the base is. So I'm going to extract the curve that defines the top of the base using the extract curve atom. Now that takes a surface and allows you to pull a curve out of that, and it could be either along U or V values. In this case I'm wanting to extract the curve that's at the very top along the U direction. There it is. And now that I've got that curve, well, I can extrude it. The default extrusion there though is on the Z axis, and it's not what we want. We want it to extrude up the Y axis by the length of the pole height. So I'll create another XYZ to vector, and link the pole height to the y-axis and connect that up to extrude curve. At the moment pole height is 0, so here we go. We now have both the pole and the base, and we want to be able to set a custom color on those, so let's create a color and make it sticky and something other than black. Let's just make it a mid-grey. Now I want to connect both the extruded curve that is the pole and the skin that is the base. I want both of those to be set the same color, so I'm going to create a set color node, and it's automatically fed that color into it, so I don't need to do that. We can see that it's connected directly to the color input. Now I want to select connect the skin, so I'll drag that onto set color and it's connected to the geometry. I also want to connect the extruded curve, so I'm going to shift and drag that. And the reason I shift dragged so is it didn't replace the skin on the input geometry, it just joined it there. So you can usually connect more than one piece of geometry to a geometry input. Now the set color can go to the output node. There's one more thing that I want to do before I've finished my lamp stand, and that is I want to output the height of the entire assembly of the stand. So I want to find out the Y position at the top here, and there are a few different ways I could do this, but the way I'm going to do it is I'm going to extract the curve that is that circle at the top of the pole. So I'm going to extract curve, and I've got to select V and 1 here to give me the very top circle around the right axis. And what I can do now is I can find out what the point at the center of the circle is. I can average those points and get the center point. So I do that using a geometric centroid atom, and I just feed the curve in there, and all it does is it just looks at all those points and says, alright, on average the average point is right in the middle, and it outputs the X, Y and Z components of that point. I want to output the Y, and now I'm going to be able to grab that top point from outside the molecule, and I'm going to be able to use it to adjust where I put the shade. So that's the conclusion to this first part. In the next part we'll be looking at how to create a shade to pop on top of this lamp stand.